Thank you, Anton, for the introduction. And I absolutely love Tim when he was mentioning about the account abstraction and how actually it long-term helps like the security because you involve like other parties here. And this actually is a good segue because that's the long-term plan. However, the short-term thing is that you need someone to be able to properly implement it. And implementing it correctly actually isn't that easy. This ERC4337 account abstraction, well, here's the subtitle. Oh, damn, it's not that easy. So this is the talk. The main author of the talk and then the tool is Po-An Ling. He's also a Taiwanese, right now based in Japan. And I am presenting because I kind of like guided with him and worked with him on this project. So, quick intro about account abstraction. So, there are a lot of benefits. I'm just like really simplifying it here, right here. First of all, it allows us to have different kind of signature schemes, so not really just limited to the ECDSA that we have right now. We have other ways to authenticate. We may have like ZK proof. We may have like cross-chain authentication, all these kind of stuff. Right, so that is awesome because that opens up different kinds of signature schemes. And other than that, we are able to have like wallet recovery. Well, like right now, even for myself, to keep the private key in a safe place, it's kind of hard. It's kind of annoying. And having the recovery thing is very user-friendly. Like, hey, I forgot my password. Like I do that a lot, probably daily. And it will be nice for wallets to have that as well. And account abstraction does provide that. Session keys as well. And also gas user experience. For example, I am paying it doesn't require for me to have Ether to pay. Right now, that is mostly the case. But later, with account abstraction, I should be able to pay the gas with USDC, with whatever token actually is in my wallet, right? So these are all the great things that comes with account abstraction. And there's a lot of different ways about account abstraction. So that's just a huge concept. It has been discussed widely in how to implement it. One of the ways that was discussed was in protocol, like you have to change the consensus mechanism, you have to change Ethereum itself, and that was sort of like put away, because that was too much work. And this is kind of like the latest one that seems to start gain adoption. And the reason for it, the first thing is actually, well, no Ethereum consensus level change, which is awesome because, like for having a consensus level change is very, very serious thing, a big thing, right? No new opcodes, it's good. And this is purely on the smart contract application level. Now, what this kind of like enables or like, opens up is like, okay, now we have a user operation, not transaction, another kind of mempool, you might say, that exists. So it creates another layer, not transaction, just some sort of like intent-like operations. And then you have another party, which is the bundler who takes in the user operation and then actually compiles it into transaction and then send it on chain. So high level, this is the case. On chain, how it does, how it works is that on Ethereum or on every chain, there should be like one single entry point that is deployed by a third party. And so you only need one such smart contract in each chain. And other people will, like as a user, I will send my user operation to a bundler. Bundler picks it up, creates transaction, send it to the entry point. That's essentially the flow. That is essentially the flow. All right. And here we go. This is the flow that we're talking about. We have users that send their user operation. So I'm going to remind you a bit how it looks like before. Before, it's user directly sends the transaction to the blockchain. Here, let's assume this part is blockchain, right? It sends directly to the blockchain, spends gas, like and all those kind of stuff. Now it creates another layer. It creates a bundler right here, and then on the Ethereum or on the blockchain, it has this entry point smart contract that is universal that interacts with all your accounts, etc. Now, the user sends the user operations to the bundler. The bundler calls a unique, like a specific function, which is called handle ops. And the entry point does a couple of things. First, it validates the operation, whether this is okay to execute. And after it validates, like, okay, everything is safe-ish, then it executes. Now, we'll need to dive a little bit more here about why do we need this validation thing. Well, the first thing is you want to prevent like the DOS issue. So here, let's go to the next one. The first thing the bundler wants to do is to check on the simulation. During the simulation, like, hey, can I execute this or not? Will this transaction revert? Because imagine, the bundler is the one that actually sends the transaction for you. So they spend the gas. So there's one huge attack vector. And basically, all the complexity of ERC, this account abstraction EIP, is around this core idea that I don't want to be DOS. And how do you get DOS? You basically, as a bundler, if when you simulate, it looks good, and then when you send a transaction, it reverts, well, then you're just wasting your gas, right? And so that is the way how the bundler can get attacked. This is the core idea, and everything, all these like complex mechanisms are basically just surrounding that, we will not go into all the details of how, like, all those like limitations. However, we can like kind of like quickly get a glance, right? So, it's just a snippet from the EIP standard itself. You see there's forbidden opcodes. There is storage restrictions, and there's reasons for that. First of all, forbidden opcodes, gas price, gas limit, difficulty, timestamp, base fee, block hash, all these things. Why? Because they change. They may change all the time, right? During your simulation, it's one thing, right? The gas price is one thing. When you actually execute, it's another value. So a lot of these are basically just non-consistent opcodes. They will return non-consistent values. And that's why they're forbidden. Because going back to the previous slide, you want to simulate, and if this one passes, then you send the transaction. And if there's inconsistencies, then there's a risk for you to get DOS. That's why these are forbidden. So, simple as that. Storage. There are two things. One is it's only able to access its own storage. So, of course, like as a contract, you can read other contract storage, etc., right? But you can also read your self-storage. So there is no restriction on reading your own storage. So that part is good. That part is okay. However, there is a restriction on external storage, and this part. So this part is actually slightly confusing. The reason that it is required to kind of like, limited to only able to access associate storage, perhaps we can think of just another like counterexample, which is I have a contract, then I'm just like reading another storage that is shared, and some other contracts will also write it. The problem with that, also going back to this thing, is that during the simulation, the state of that external contract can be one thing, right? And when you actually send a transaction, just imagine literally you got front run. Someone else changed that storage. And that will essentially revert your transaction. And so it goes back to the same principle. You don't want to get revert. You don't want to get DOS. So that's the reason. But why do we allow associated storage? And what is associated storage? Associated storage basically means that storage that will, well, as the name suggests, associated to me, right? So for example, if I am a wallet, I want to be able to access, like, hey, my balance, my ERC20 balance in some random tokens, right? And how do you do that? You call balance address, right? And then you get your own like balance. That's how you obtain your own balance. And balance address is exactly this. In the opcode or in the deeper level, it is exactly saying that, hey, I want to calculate this number and access that storage that is related to me. That's why they define these seemingly complicated things, like, oh, KCHAC 256 and an A or X and plus N. Like, basically, it wants to still enable or allow the use cases that I am, like ERC20 tokens balance address, and this address is my wallet's address, right? So it wants to be able to like, hey, this is a common use case. Let's allow that. So that's being defined as associated storage. All right. Now, that is sort of easy to understand because you have the basic principle, and then that's hopefully after my explanation, like the principle itself is easy to understand. However, it's hard to remember. Like, hey, look at all this thing. How would you remember this thing? And then when you are writing the smart contract, you're not even looking at these things. These are in the opcode level, right? You're not really looking at these stuff. Like, so it is actually hard to detect. And not only that, actually, we're going to talk about it in a sec. So, of course, when you're writing, it's easy to forget, like, hey, these limitations exist. So, obviously, you're going to write, it's possible that you write something that will violate the EIP. And, of course, that's a problem. The problem is not as severe as other vulnerabilities. Other vulnerabilities, it could be like, oh, you will get wrecked, like my funds get lost, and like someone will steal my stuff. And these type of things is essentially kind of like DOS. Like going back to this one, the effect of you writing a smart contract that violates the EIP itself is when your user sends a user operation, that user operation just violates the rule. And the bundler, if they are security aware, they should drop it. So essentially, your user operation will go nowhere. And your user will complain like, what the heck? Where is my transaction? You promised me a better user experience, and I have, no transaction on chain, I guess, hardly maybe a good experience. I don't know. I think it's strictly worse. You're not getting anywhere. So that is the issue, not as severe, but it's like this whole thing is for improving your user experience, but you're not now getting DOS. So not good. The common pitfalls that we saw, other than just like you literally forget that you shouldn't implement that, the thing is, there's a lot of patterns that we have adopted when we're like writing smart contracts. Like as one of the example is beacon upgrade, right? You have a proxy that points to a beacon, and this beacon points to an actual implementation. It's easy, super easy to upgrade this way. Like you don't need to call each individual proxy like, hey, upgrade, hey, upgrade, hey, upgrade. You don't need to do that anymore. Now you just need to go to the beacon and say like, hey, please upgrade the whole thing, the whole implementation, and you're good. That is a very, like life hack for smart contract devs, but this doesn't work in this EIP. And the reason for that is simple. Because you're the proxy, right? This is the main contract address. And the users, well, this is the address that you're talking to. This proxy, if you're following the beacon pattern, then it goes to the beacon, and the beacon reads it from somewhere. And this is not associate storage, because it doesn't store for your proxy, like what is your proxy's implementation? What's the other proxy's implementation? It's not specific to every proxy. It's actually shared by everyone, right? Everyone's actually reading the same storage slot. That's the whole design of Beacon. But that is exactly the design that is against the standard of EIP. So wrecked. This Beacon upgrade pattern in account abstraction, wrecked. It's easy to now, if you look back, it seems easy, but actually it's very hard to detect, because when you write, you actually write the implementation. You write the implementation, you don't really think of what kind of proxy that you are going to use. That's the annoying part. That's the annoying part. So when you, as a dev, you look at your EIP standard, and you're like, oh, you know, I have avoided all the pitfalls for smart contracts of writing this standard. And then maybe another smart contract dev, or just you losing some context, and like, you know, Beacon is a very natural thing, very nice thing to just like integrate, and you just like hook them up, and it just doesn't work. So the point here, it's integration level. The reason why it's hard, it's not only there are so many limitations, but also a lot of limitations, or a lot of like these issues comes up during the integration. This is another, well, another kind of like idea, like what may go wrong, right? So you have a wallet contract. Imagine this wallet contract goes to an external contract that reads maybe Oracle, registry, ENS, right? It's sort of natural. I want to enhance my user experience. I want to query some ENS, and then like, hey, you know, then you can transfer the funds directly, whatever. And or you have a role-based account control, right? And this is also, well, I wouldn't say common, but it's not unfamiliar, or it's not unheard of. You want your smart contract to have like, oh, you know, different kinds of role, etc. But if you now switch your brain not from the business side and business logic side into the smart contract development side, then you'll be like, oh shit, this actually is reading a storage that is very specific. Like, it's not associated storage. Again, so again, it's integration level, very hard to detect. That's the you know, the issues of these things. Now, we have been doing some work around this for quite some time, like doing several audits, etc. And then we realized that this is, well, of course you can rely and like hope for the best, like for a human to detect all these things, but it's these things, you know, it's better solved by a machine, by a tool. That's what we did. And so we started this like kind of like small project to work on. And essentially, we looked at different kind of ways to do it. The first one is static analysis. Well, static analysis, you take the code, you analyze its bytecode, or analyze its source code, whatever. Then a couple challenges, I won't go into the details, but a couple challenges actually arise. The first thing, it's actually hard to know the storage slot, like whether you're getting actually the associated storage, right? The second thing is related to what I was talking about, the integration time. Like when you integrate, that's exactly on runtime. Like you know, during runtime, does it invoke any forbidden opcodes? So static analysis doesn't do that, because it literally just looks at this file or the bytecode that this file compiles into. So not good, not good. It doesn't solve our problem. There is bundler simulation, which makes sense. That's why it's yellow. You have, if you follow through the ERC4337, then you'll see that, hey, they do provide like a bundler, and you can run it. You can, just like simulate the whole transaction. This is not easy to do. This is not easy to do. You have to simulate. There's like so many steps. Like every time I want to run such a simulation, I recall like spending hours. Like, oh, okay, I forgot about that. I need to deploy my smart contract into this like fake get or whatever. This is actually very hard to do. So the user experience from the developer side or auditor side is really, really bad. And it has at least like 3 components or 4 components now in my mind, because I've done that. Like I basically have 4 small screens, and one doing simulation, with the other doing get, the other trying to deploy smart contract, and this one running the test. But boom, I forgot to do something else that I need to do. Rerun the whole thing. Not good. So the other thing is the execution, the simulation. It's also hard because it's you then need to port all of the possible or like the common actions that this system is doing to this simulation that you have been doing. And so you're basically doubling your work in that sense. What we really want is that, hey, there is, devs write tests. Well, actually, let me clarify or correct that, modify that statement a bit. Great devs write tests. As auditors know, and I see auditors smiling, that not all devs write tests, unfortunately, but great devs write tests, right? And so if they write tests, we want a very simple way for them to be able to, or just modify a little bit, and they'll be able to detect. And that's exactly what we went for. Won't go into the details again, but essentially what we went for is okay, let's modify Forge. With Forge, of course, well, the reason why is that it's Forge test, right? That's what we want to work with. We don't want to spin out another get. We just want to directly simulate it with Forge during the test. Great. What we did in a nutshell is basically, did some cheat codes or let's say extensions within Forge that's easier to understand. And then what this allows is that we're checking all of these limitations during the test, during the Forge test. I think, I did not put that part here, but essentially what we need to do is taking a developer's test, modify it, literally 2 lines, to invoke this, this cheat code, and then just run it. So originally the test would pass. Then it, with this modification, if it kind of touches these forbidden opcodes, then it will just fail. As simple as that. So the user experience from the devs or auditors' perspectives are great. And so this is what we did, and we're okay, great. See, Andy's MacBook Pro. So the author is Andy. We were trying to find examples for this presentation. We're we did an awesome tooling. We ran on our clients, and our clients didn't have this issue for this. And we're well, it's not fun if you cannot find any examples. So we just tried to download other ERC, open source ones, and then just ran the tool. And then we found one openly. It's just out there. Then we, of course, went in, contacted them, let them know. There's some interesting things that right now you should know, but it's something just interesting facts. Because this whole bundler thing are new, so bundler actually, a lot of the bundlers actually don't care whether you have sent forbidden opcode or not. They literally just accept everything. So this bug went undetected for a long time until they noticed hey, some of the user opcode were getting dropped by some of the bundlers. And why is that? And some others are yeah, this is fine. I'll take everything. So it was fun. So we went and discussed, how to disclosure. It's not serious because it's mostly like a user experience, like a DOS kind of thing. But from that point of view, the whole point of this ERC is to create a better user experience. Now you have no user experience at all. Yeah, not great, right? So we were able to find these in the wild and very, very easily. And that's how simple it should be for approaching these things. Cool. I think I'm gonna wrap up. Basically, some conclusion. We have worked on a lot on these like account abstraction, and like these, what I just mentioned is basically our experience on auditing. Like one of the harder parts here, integration tests. So you have to have tooling. There's like so many limitations, and then like on the integration, it's very hard. This is integration. This is too many limitations. Like both are hard for human, devs and auditors alike. So this is where tooling should help. Unfortunately, the tool is still work in progress, so we haven't open sourced it yet. Haven't yet, but it's I think it is worthwhile to just tell people like, hey, this one, there's this issue. One, whoever is implementing this account abstraction thing need to think about this. At least notice like these kind of restrictions exist. I think the integration part is really, really tricky. Because we had great developers that write all the tests, like had like 100 coverage. They still encountered this issue when they were thinking about the use cases. They're like, oh, we can link up this account to another account, and then we can do this and that. And then at the time, we didn't have the tooling, and we were just like poking around and luckily came across the scenario like, well, actually, the storage slot will not work right there. That's where it kind of like all started, right? This is just a reference for our past work with Alchemy. So we have worked on 4337 and also like their advanced version that is pushed by Alchemy, the 69, nice number, right? I know, 6900. So yeah, that's about it. Thank you for listening. Any questions? Questions? Yes, sir.
Yeah, first of all, thank you for a great presentation as well. It was a pleasure to read, and also a pleasure to read 6900 as well. Hope someday we have this live. So did you try to use also instead of Geth the Anvil node? Did it work?
Sorry, use what?
The Anvil node from Foundry.
Annual node. Anvil code?
Anvil node. There is.
I don't think we. Actually, I'm not sure because the author is not me. But I didn't get the report that we're trying on that route. So
yeah.
Yeah,
and then maybe generally a question like, what do you think with the wallets that users are going to use? What kind of standardization you would like to see there?
The rollouts of the account abstraction? Or
the standardization around that. The question really is about like, did the bundlers really lose money on doing this wrong transactions?
Oh, you mean like why didn't they drop it?
Well, did you do statistics about
statistics? No, we did not do the statistics. We just noticed that like kind of like in the interesting fashion, like like this one is dropping it, that one is not, and then like it should be dropping, and so that's how we kind of like observed it, but we didn't actually because I think it's very it's basically per company their decision, and with bundler it's basically you have business relationship and then you send the operations to them. You can do statistics, but it's also kind of like, I guess, market cap kind of thing.
Yeah, it's like inclining to the vulnerability management of that thing. Like, if people are losing money on that.
That part, and I think that is the part that we felt it was okay-ish, because the violation of this one actually won't get you really stuck. So you're just, as a user, you're just not able to send the user up, right? So going back here, you're just stuck here. But as a user, you can still directly send your transactions over to the wallet, unless the implementation strictly forbids that, which is typically not the case. So like, I feel like in this EIP, when the violation happens, most likely there's not as serious in the sense of monetary loss. So that's the good thing about this whole complexity. But the bad thing is, like, yeah, you don't get user experience at all.
Thank you.
Thank you, sir, for your question. Any other questions? Yes, sir.
Yeah, thanks, Martin, for the great presentation. And yeah, I just wondering that since all of these things comes from the attraction of the bundlers, you made the videos. So I'm just curious about that. Is there any other way to build the old structure for the account abstraction with the feature that do not change the foundation of the OB codes or anything? Maybe just that the DDoS users will be punished at some point. I don't know. Yeah, but maybe it can work around this attack with another ideas. Yeah, I don't know.
Yeah, well, from my kind of understanding on the whole account abstraction or this intent kind of field, this design is more like easier on the protocol side. So there are other ways for sure, right? Like you change the whole protocol and then there's like huge change right there. Yeah. And from the user or from the smart contract development side, that's easy. Like you don't even need to change much, right? Yeah. But if you think about it practically, like, hey, I'm going to coordinate all of these nodes to actually do the hard fork on that, and then like have probably previous EOAs to migrate over, whatever. That is much harder. Yeah, yeah. So I think in terms of like Ethereum specifically, this is kind of a good alternative in my opinion. So.
Yeah. Okay. Thank you. And looking forward that the tooling will be open source soon.
Yeah. Yeah. All right. If no other questions, then this is great. Thank you, everyone.